All right, this is a video over the AP Stats test, a quick review over significance testing. One of the most difficult topics on the test, but also, in my opinion, one of the easiest to understand if you truly grasp the concept. So first, what is a significance test all about? We're testing to see if a claim about a population parameter is true or not. You are looking for evidence to support the claim. Otherwise, you do not have evidence to support the claim. A significance test is all about comparing statistics from a sample to something we believe was true, called the null hypothesis. If our sample statistic is significantly far from the believed truth, then we do have significant evidence to support our claim. So a significance test is all based around this idea that somebody tells us a truth, whether it be a true mu or a true p. And then we want to decide if that truth is still valid, or maybe it's something more or less, or just something different. But to understand that, we need a sample statistic, either a mean or a sample proportion. And then we have to determine how significant is that sample mean? How significant is that sample proportion? And we do so with a t-score or a z-score. Once we have our t-score, z-score, we can calculate what is known as the p-value, and that p-value is the probability of seeing that statistic occur, or more extreme, assuming the null is true. And with that p-value, we can make a conclusion about our question. Do we have significant evidence? And we're going to talk all about that in this video. All right, so first and foremost, know that a significance test involves 4 steps: your hypotheses, the conditions, the work to find the p-value, and a conclusion in context. I love to recommend to label the steps. The AP graders really love that. So there are actually 5 different types of significance tests. There's even more than that, but for right now we're just going to focus on 5. Now, the first one focuses around a single proportion. Okay? Now, here our null would be that a given proportion is true. Like, we believe that the true proportion is 15%. That's the null. The alternative is we're going to wonder one of 3 things. Either the true proportion is less than 15%, greater than 15%, or simply something different than 15%. And you got to read the problem to know which one that is. We can also have a test that focuses on a single mean. So the null would be what the problem states. The problem states that the true mean is 300. And our alternative is going to be one of 3 options. The true mean is less than, greater than, or simply something different than 300. Now we could also look at 2 proportions. Now when we're looking at 2 proportions, what we care about is the difference between them. Our null is always that the difference between the 2 proportions is 0, which means that the 2 proportions are the same. Now in this type of test, we're talking about the difference between 2 proportions pulled from 2 populations. So maybe guys versus girls, older people versus younger people, Republicans versus Democrats. Again, we're looking at the difference between 2 proportions pulled from 2 independent proportions or populations. And then the alternative is, and you got to read the question, do we think one is less than, greater than, or maybe just something different than proportion 2? And the other test we could look at is a 2-sample mean test. And here, once again, we're looking at the mean between 2 samples, and those 2 samples are taken independently from 2 different populations. And we want to concern, is the mean for guys equal to the mean for girls? And this would be the null, that there is no difference. The difference is 0, which means that they are equal. And the alternative would be, maybe guys really are greater than, or less than, or different than the mean for girls. Whatever, 2 different populations. Now the 5th test I was referencing is for a matched pairs test. So a matched pairs test, it looks like there's 2 different samples, but there's really only 1 sample that we measure twice, maybe before or an after, or with your left arm and then with your right arm. The difference is that there's only 1 sample. So we call this a matched pairs test because there's only 1 sample, And in that case, all we truly care about is the average difference between those two samples. And we assume that the null is that there is no difference, and the alternative is that there is a difference. Again, whether you think it's less than, greater than, or just something other than 0. But the key trick there is that, it looks like there's two samples, but it's only one set of data that we just measured twice. So in that case, all we care about is the differences. Now I'm going to show you an example of all 5 of these at the end of this video, but I'm just trying to get you to understand the first step, which is the hypotheses. The conditions is also important. The first 2 conditions are always the same. The sample or samples must be random to avoid bias. The sample or samples must be under 10% of the population so that independence can be assumed. And the third condition is that we got to have that normalcy, right? We got to assume the normal model is possible here. With proportions, you need to show that your data has 10 or more successes and 10 or more failures. Excuse me. With means, it's kind of tricky. With means to show that you're normal, you have a couple options. Number 1, if the population is stated to be normal, any sample size is big enough for the normal model. If the population is non-normal or unknown, then the central limit theorem can help you and say that the model will be normal as long as your your sample size is 30 or larger. However, if your data is below 30 and you don't know what your population looks like, then you do have to make sure that your data looks approximately normal. So you do need to take a quick look at a graph of your data and make sure that there's no major skewness or major outliers. So those are the conditions which hopefully your teacher has taught you very well at this point. Then we got to focus on finding that p-value. And that depends what type of test you're on. Now, anytime you're working with proportions, you're talking about a z-test. Anytime you're talking about means, you're working at the t-test. The primary reason why we have to use a t-test is because when we calculate standard error, we have to use the standard deviation of our sample divided by the square root of sample size. And that means that we don't know sigma, the true standard deviation of the population. We're replacing that with S, the standard deviation of our sample. That creates a lot more variance in the problem, which is why we have to use the new t model. So let's talk about proportions first with the z model. Now, you're going to have your null hypothesis. Your null hypothesis, again, I'm going to use the example of above. Your null hypothesis is that the truth is 15%. That means the standard deviation that we're going to use for our model is based off of that truth, 0.15 times 0.85 divided by your sample size, whatever that may be. And then you're also going to have your sample proportion. Now, this is what you found in your sample. So if my alternative was that I think the truth is something greater than 15%, maybe my p-hat is something like 18%. Now, the idea is 18% is bigger than 15%, but is it significantly bigger? Is it so much bigger that it means that the truth is not 15%? Again, that's what we're analyzing. So to do this, all we have to do is calculate a z-score for our p-hat. So we're going to take 0.18 minus 0.15, divide by the standard error, which I just showed you how to calculate. That's going to get you a z-score. Once you have that z-score, you can calculate your p-value. The p-value is the probability of your sample statistic occurring, or more extreme, assuming the null is true. And then to find that p-value, I would use normal CDF, and you would look above it because it's a positive z-score and alternative is greater than, and that's going to get you your p-value. And your p-value will be used to make your decision. Now, if it's a two-proportion test, looking at the difference between two proportions, remember our null is that there is no difference between the two proportions. Now, the p-hat, you're going to have two of them. You're going to have a p-hat from your first sample, and you're going to have a p-hat from your second sample. And they're going to show a difference. And the question is it a significant difference? So let's just say that the difference between your two samples was something like 0.02. Maybe the first sample was 0.05 and the second sample was 0.03. That produced a sample difference of 0.02. So what we need to do is find out how rare, how significant is a 2% difference. Is it just like, probably just sampling variability, or is it, no, there is a difference, one proportion is greater than the other? Well, we need to calculate a z-score, so we're going to need a standard error for this. The formula for standard error here is going to be looking at the two proportions. So we got the first proportion 0.05, times 0.95 divided by that sample size, whatever it may be, plus the second proportion, 0.03 times 0.97 divided by that second sample size, whatever that may be. Then your z-score is going to be your difference, which for us was 0.02, minus the difference we expected, which was 0. We expected no difference, divided by that standard error. Once again, with that z-score, you could use normal CDF to calculate your p-value. Now, some teachers will teach you that for the standard error here, you should pull your data together. You don't have to pull. You could still get away with not pulling and still get the question correct. It is recommended that you pull, though. When I show an example at the end of this video, you will see an example of pulling. All right, now let's focus on means real quick. All right, so it's the same idea. Your null hypothesis tells you that the mean is supposed to be 300. Well, our sample showed, 250. Well, is that enough evidence that the truth is really something lower? Well, we need to calculate t-score, but first we need our standard error. Standard error is going to be taking S, the standard deviation from our sample, which should be given to you, or you could calculate, divided by the square root of your sample size. Then you're going to calculate a t-score, which is taking your sample minus the null that you thought was true, all divided by your sample size, your standard error. And that's going to produce a test statistic or a t-score. You could then find your p-value. I would use t-CDF to find that p-value on your calculator. The only thing you're going to need to know is your degrees of freedom. Your degrees of freedom is your sample size minus 1. It's that simple. All right, so looking at the difference between two samples. So remember, our null is that the difference between the two samples is non-existent because they're equal. There is no difference. Well, our sample from population 1 might have been, 250, and our sample from population 2 might have been, 260. Okay, that is a difference of 10. That is a 10 difference. Now I'm just using random numbers here with no units to be generic, but 10. All right, so I got to find how significant is a difference of 10. And to do that, I need a t-score. I'm going to take my difference of 10, subtract 0, because there was no difference. Now, the only thing here is I need a standard error. So how do you calculate standard error for two samples? Well, you need the standard deviation from the first sample squared divided by sample size, plus the standard deviation from your second sample squared divided by sample size. Now, those sample sizes will be given to you in the problem, and so should those standard deviations, or you can calculate them on your own. And that's going to get you your standard error there. Once again, you can then use t-CDF to find your p-value. Now, what about degrees of freedom here? Now, degrees of freedom you could use, take your sample size minus 1 from your first sample, add to it your sample size minus 1 from your second sample. So that's your total degrees of freedom. Degrees of freedom from the first sample plus degrees of freedom from the second sample. Or you could actually use the smaller of the two. So whatever is the smallest between the degrees of freedom from sample 1 and the degrees of freedom from sample 2. So that's pretty much the steps there for the the work actually to calculate that p-value in a nutshell. But I quickly want to talk about your conclusion next. All right, you need to base your conclusion on your p-value. And what we're looking for here is, how do we compare this? How do we know if we have something significant or not? And that's where we need an alpha level. This is our level of significance. We typically use 1% or 5% as our level of significance. Now, if your p-value is less than 0.01 or 0.05, whatever one you're choosing, that is when you do have evidence to go with the alternative. This is when we would reject the null. There is evidence to go with the alternative. Now, what we're saying here is that what we saw, the statistic that we saw, was very unlikely. That's the p-value, the probability of your statistic occurring, or more extreme, if the null is true. So if the null is true, the probability of our sample occurring was very low. And if the probability of our sample occurring is very low, but the sample did occur, well, what that means is that we're seeing something significant and that we should reject the null and go with the alternative. We never accept the null. We just say, hey, listen, our sample is very significant, significantly low or significantly high, and that does give us the evidence that the null is wrong, and we're going to go ahead and reject it. Now, if your p-value, I'm having a hard time writing today. Excuse me. If your p-value is greater than your alpha of 0.01, or again, if you're using 0.05, this is when you fail to reject the null. This means that there is no significant evidence that the alternative is true. When we fail to reject the null, basically we're saying, hey, listen, the probability of our sample occurring or more extreme is actually quite likely. It means that our sample was not what we intended. It was a little bit more or maybe a little bit less, but it was just a little bit. It wasn't anything significant. And that means that the null still could be true. So notice that we just failed to reject the null. We don't accept the null. We don't say the null is true. We just do not have enough evidence to go against it. Okay? So at no point do we say, oh, the null is true. The truth really is 15%. No, we just don't have enough evidence to think otherwise. Okay? So that's really important. So hopefully you understand all that. Now, a confidence interval should also connect to your conclusion in a test. So let's kind of go back over here for a second. I just want to take a quick look at one of our hypotheses. Let's go look at this single proportion here. Now, if the truth is 15% and we're concerned that it's higher, okay, greater than, let's say that we take a look at some evidence. Let's maybe our p-hat is something like 18% and we get a p-value that is very low, 0.0001. That means we're going to reject the null and that the alternative is true. We do have evidence that the alternative is true, that it's greater than 15%. Now, if we were to construct a 95% confidence interval, we would probably see something like this. And I'm just totally making this up. But the point that I'm trying to make based on this interval, and please, I'm just making this interval up, is just the fact that this interval does show that the truth is somewhere greater than 15%. We don't know exactly what the truth is. We just do know that it's greater than 15%. If our p-value was higher, above 0.01 or 0.05, then we would fail to reject the null. That would produce maybe an interval like this. This interval shows that, well, 15% could be true, so I can't necessarily say that the truth is definitely greater than 15% if the interval says that it could be 15%. I know I'm going through all this very fast, but again, this is a lot of the ideas and the details that should have been discussed in class. I'm just trying to give you a quick rundown of how to conduct one of these tests and how to find the test statistic, whether it be a z-score or a t-score, and your p-value. Now, what I want to actually do is show you an example of confidence intervals and tests. Now, I'm not going to talk here. I'm just going to briefly talk about introing each problem. If you want to take the time to pause, read each problem, see my work to see how each of these different tests can be done, I would highly recommend doing that. I'm going to go through them fairly fast, but you have the capability to hit pause. That way you could read the problem and show my work. All right, so here is a 1 proportion z interval. Go ahead and take the time now to pause, read the problem, and then look at my work as I scroll through it. Here's a 1 proportion z test. Here is a 2 proportion z interval. Here is a 2 proportion z test. Here's a one sample t interval for means. Here's an example of a one sample t-test. Here's an example of a two sample t interval. Here's an example of a two sample t-test. And finally, here's one of those two sample paired tests for the difference between two means. This is where there's really only one set of data that was just measured twice, or with two different methods in this case. Alright, so hopefully you were able to see enough in this video to just give you a quick reminder of how to do a significance test. They're really not that bad. The work is the most important part. You need to calculate that z-score or that t-score, that's the test statistic, and just think about taking, your sample minus the null divided by that standard error. Keep in mind the last page of your formula sheet has those standard error formulas on it. And then for a mean, you're talking about a sample mean minus the null divided by a standard error. And then with that z-score or t-score, you could calculate that p-value. And that p-value is really important to understand. It's the probability of your sample occurring or more extreme, assuming that the null is true. And if that p-value is very small, what you're witnessing is very significant, which gives you evidence to reject the null and go with the alternative. If your p-value is quite large, well, you just don't have anything significant. What you have is probably just sampling variability. You're not seeing exactly with what you thought you were going to see, but it's no big deal. It's just that things vary. So hopefully my examples helped you. I would really recommend taking the time to look over them, pausing the video, and seeing my work and my explanations. I think it'll go a long way in helping you study for the AP test. Thanks and good luck.